Hello students, now we are going to start second unit of crash course, that is Newton's laws of motion and work power energy. Unit 2. Of your crash course. It is Newton's laws, work, power, and energy. First, we are talking about Newton's laws of motion. You know that there are three laws of motion. From first law, they are generally asking conceptual problems. It is known as law of inertia. You all are aware of this law from 9th class. It is again a topic of 9th class. Newton's law of work, power, energy. First law is known as law of inertia. What is the measure of inertia? Inertia means tendency to oppose in the change of position of rest, position of motion, position of direction. So it means there are three types of inertia. Inertia related to state of rest. Inertia related to state of motion. Inertia related to direction of motion. What is the measure of inertia? Measure of inertia is mass. See, if 100 kg an object is placed at some place, you cannot change its position easily. It has too much resistance. But a 1 kg stone, anytime you can put from this place to that place, because it cannot oppose you. Less mass, less power of opposing your force. So first thing is this, that measure of inertia is mass. Getting my point? Some tough conceptual problems they are asking based on this first law. Suppose you are traveling in a train and you are sitting on a seat, or you are standing on the passage between seats, 6 seats or 4 seats on one side, 2 seats on second side. That passage is there. You are standing in passage. You tossed a coin. Train is accelerating. So coin will come in your hand, or it will fall in front of you, or it will fall behind you. Or nothing can be said. They can make this type of 4 options. What will happen if you are standing in a accelerated train and you toss a coin? See, you were the part of the train. With train you were also accelerating. It means your speed is continuously increasing. When you toss the coin, at that time, what was the velocity of that coin? Now the coin is in air. It will move. Now it is not the part of train, it is in air. But your feet are on the floor of train and train is accelerating means you are accelerating. So now you are moving with speed greater than the speed of coin. When coin will come back, up to that time your speed is increased. So you will move forward and the coin will fall behind you. It's with same reason, if you are on retarding train, the speed of coin is more than speed of you. So coin will fall in front of you. If train is moving with a constant speed, it will come again at your hand. Getting my point? So they can ask this type of problem based to first law. They can ask you, in which portion of a swimming competition swimmer spent its most energy, first 1/3 part, second 1/3 part or last 1/3 part? Again, concept is very simple. For first 1/3 part, he need more energy because he has to overcome its state of rest. Before starting swimming, he was at rest. So inertia will oppose when he will start swimming. So he has to overcome this inertia. So he need more energy in first 1/3 part. So in this type of questions, they can ask in competitive exams. Second law, they can ask which law is most general law. First law is law of inertia. Second law, which is defining force, that rate of change of momentum is equal to applied force. The only law which is purely mathematical, and you can derive third and first law from the second law. So we are saying most general law is second law. That rate of change of momentum is directly proportional to applied force. And proportionality constant means first we will write this, and when you are going to remove this, we will choose the units so that constant of proportionality will become 1. So we can say F is equals to dP by dt. Or you can go further to mass into acceleration. It was Newton's second law. What was Newton's third law? Every action has equal and opposite reaction. What is the use of this third law? Due to this third law, walking is possible on the ground. How walking is possible? You are pushing earth in backward direction and reactionary force of earth. You are walking with the help of this force only. But one question arises. If Newton's third law is helping us in walking, but we are saying action and reaction are opposite and equal, so two opposite and equal forces, they should cancel each other. So how walking is possible? Remember, I am putting one ball at this place. You are pulling in your direction with force F, and your friend is pulling in his direction with again force F. Both are equally strong. Where ball will go? Nowhere. Because both forces are equal and opposite in direction, they will cancel each other. But it is not your case. See this now. These are two balls not connected with each other. You are pulling this ball in your direction with force F. Your friend is pulling this ball in his direction. Since balls are not connected, it will go in this direction, it will go in this direction. These forces cannot cancel each other. It is your case. Why action and reaction in that case cannot cancel each other? Why Newton's law's third law Newton's? Why action and reaction cannot cancel each other? Because they are acting on two different bodies. Your action is acting on earth, but that small force cannot overcome the inertia of earth. Its mass is too much. But reaction of earth, which is acting on you, it can move you. Your mass is not of that order. So it was Newton's third law. We will take at many places the help of this reaction. What you are doing when you are on a bike or bicycle and suddenly road is turned, means one circular turn is there. To keep on that circular turn, you need centripetal force. What you will do? You will little tilt your vehicle and you will make free one part of reaction and force from earth. This will provide you centripetal force. Getting my point? We will discuss in detail in theory these all concepts. So it was the role of that Newton's third law. Mostly in competitive exams, they are asking tension related problems. So they are very, very important in Newton's this law. First is this: rate of change of momentum is equals to force. It means force into dt, it should be equal to dp, change in momentum. This term is known as impulse. So impulse means change in momentum. It plays a big role in daily life. A ball is coming with very speed towards a player. He wants to catch the ball. What he will do? He will not put his hand in like stationary. When ball will come in his hand, he will take his hand back. Why he is doing this? Due to this relation he is doing this. You know that force into time, this time interval, is equals to change in momentum. Suppose mass of ball was m and velocity was v. He wants to catch the ball. He wants to make the momentum of ball 0. Initial momentum was m into v. After catching the ball, its momentum was 0. If he do this action in a short interval of time, it means dt is less, but dp is constant. Anyhow, you have to make mv 0. So this term is constant now. If you do this in short interval of time, the value of f will increase. It means ball will hit your palms with a high force. If you increase this, f will be small. To increase the time interval in which he make this momentum 0, he is taking his hand slowly backward direction. I think you understand the action of the player, why he is doing this. Why it is unsafe to jump on a hard floor? Because if you are jumping from a height, before hitting the first, suppose your velocity was v, your mass was m, your momentum was m into v. If first is hard, just after collision, your momentum will become 0. If it is soft like sand, it will take time to become 0. Again, same picture is there. dp is constant. If this process is happening in a short interval of time, force will be very big. See, if you want to make mv momentum 0, in 0.1 second, suppose momentum was, mass of ball was 1 kg, velocity was 10 meter per second, or suppose 10 meter per second, so momentum was 10. If you are making this thing 0 in 0.1 second, what should be the value of F? 10 upon 0.1 means 100 Newton. If you are taking a time of 2 seconds, this force will become 5 Newton. What a great difference. Means if the process of catching the ball is 2 seconds, ball will put a force on your palms 5 Newton. But if you keep your hand stationary or little bit back, you complete this process in 0.1 second, ball will hit your palm with force 100 Newton. Next thing, in examination, they are generally asking tension type problems. What to do in that? See, it is a pulley, fixed pulley. It is mass m1. It is a mass m2. Mass m1. Suppose m1 is greater than m2. It means it is going in this direction, it is going in this direction. Since both are connected by same string, so by which acceleration it will move downward? With same acceleration it will move upward. Since the string is same, so tension is in a string, it should be same. Weight of this mass is acting downward. Again, weight of this mass is acting downward. Make a free body diagram. Means only the things you required. Only take that things. So I am talking about this mass m1. How many forces are acting on this? Tension T in this direction. m1g in this direction. Since it is moving with acceleration in this direction, which force should be greater? Definitely m1g. It means it is coming downward with a force m1g minus t, but according to Newton's second law, it should be m1 into a. Now I am talking about m2. m2g is acting in downward direction, tension T in upward direction. It is moving in upward direction with acceleration a. It means T should be greater than m2g. So by which force it is going upward? T minus m2g. But according to Newton's second law, it should be m2a. Add these two equations, you will get the acceleration m1 minus m2 into g upon m1 plus m2. It is the value of a. If you put the value of a in any one of equation, you will get tension 2m1 m2g upon m1 plus m2. But sometimes they are confusing you. What they are doing? They gave you one rope of uniform length L. What do you mean by uniform rope? Means mass is uniformly distributed. Every unit mass, unit length has same mass. And we are applying a force F on this end. They will say, from this end at distance x, calculate tension on this part. How to solve? No two masses are there. See, I am breaking the rope. I am cutting this rope. I am cutting this rope in two parts. One is this and second one is this. Its mass we can calculate. Suppose mass of whole length L is m. It means mass of unit length should be m upon L. Mass of unit length should be m upon L. So this part has length L minus x. So mass of this part should be m upon L into L minus x. And the role of tension is to pull this part with same acceleration with which this rope is moving. If mass of rope is m and you are applying a force of F, acceleration of rope should be F upon m. This part is also moving with same acceleration. So value of tension should be m upon L, mass of this part into acceleration. But what is the value of acceleration? We know that it is F upon m. Mass was not given, it is cancelled out. So in given terms, tension should be, take L inside, 1 minus x by L into F. So it was easy. Problem is very easy, only we have to focus on simple basics. Which force is acting in which direction? They can give you like this, a table. One mass they can put on table, m1. Second mass they can put on this. Both are connected. If it is going with acceleration a in downward direction, it will move in this direction. Tension in this part is pulling this, and in this part blocking the downward motion. Weight is acting in downward direction. Again, two unknowns A and T are there. If they want to calculate A or T, you can make two equations. T's role is only to pull m1 with acceleration A. And on m2, two forces are acting. Bigger one is m2g because it is going in downward direction. But according to Newton's second law, it should be m1a. It should be m2 into a. Mass is m2. Put the value of T. You will get m2g is equals to m1a plus m2a. So we got the value of A, m2g by m1 plus m2. By putting the value of A in this T, we got the value of T, m1 m2g upon m1 plus m2. They can ask this type of problem also. You have 2, 3 or 4 masses. And we are applying a force F. What should be the tension in this part? Since all masses are connected, so they will move with same acceleration. Acceleration means force upon mass. Total mass is m1 plus m2 plus m3. What is the role of tension in this part? To pull these two masses with the same acceleration. So T is mass into acceleration. So we got the value of tension in that portion. When they are including friction in this, what is the role of friction? Only 2-3 things you have to add. Friction is nothing but a self-adjusting force. The nature of friction is to oppose the motion always. If it is a block and it appears due to the roughness of the surfaces in contact. If you will see with microscope, no surface is perfectly smooth. So due to roughness of surfaces, there is interlocking which is opposing the motion. If you want to pull this block with force P in this direction, friction will come in this direction to oppose your action. But if you want to pull in this direction, it will reverse its direction to that. So direction of force is not fixed. It can increase its value by itself only. Means if you are pushing, see, I am putting this block on this surface. I am applying a little force, it is not moving. Suppose my force is 0.1 Newton, it is not moving. I am increasing the pressure, means making my force 0.2, again it is not moving. But at 0.3, suppose it is moving. It means up to 0.3, friction force was increasing its value by itself. But after a certain limit, it cannot increase its value, which is known as limiting friction. After that, if you are applying a force bigger than that, then it will start moving. Getting my point? So, with limiting friction, we have two rules. If we are putting this block on this surface, it will push the block downward by its weight. Earth's reaction is in upward direction. Since it is not moving in any direction, means R is adjusted with mg. And you are applying a force P and it is just going to start. It means your force is equal to F. What they are saying? Ratio of F and R is always constant for given surfaces. It means if you increase the weight on this mass, F will increase its value also. If these surfaces are fixed, this ratio will be same and it is known as coefficient of static friction. And if this block is moving, it is known as coefficient of kinetic friction, which is little bit less than mu s. It was first law. Second law was this, ki resultant of frictional force and normal reaction means R dash. If it is making an angle lambda with normal reaction, it is known as angle of friction. Since these are the component, it is resultant, it means its component in this direction should be F. So F should be R dash 10 lambda, resolution of vectors. R should be R dash cos lambda, because with this line it is making angle lambda. So F upon R dash will cancel out, sin lambda, it is sin lambda, perpendicular component. So sin upon cos, it will become 10 lambda. It means mu should be equal to 10 lambda. It is angle of friction. It is known as angle of friction. So with friction, they can ask so many problems. Only you have to deal just like forces. They can put it on inclined plane. What is the minimum force to pull this block in downward direction if its mass is m and coefficient of friction is mu? See, you want to pull the block in upward direction, so friction will act in downward direction. Weight's component mg sin theta, it will also act in downward direction. So if you want to pull this in upward direction, your effort should be minimum mg sin theta plus mg sin theta plus F. What is F? F is mu into R. What is R? This component should be mg cos theta, because this angle is theta. So normal reaction should be equal to this. Means mg sin theta plus mu R means mg cos theta. So they can include the friction, but only you have to keep in your mind one thing. F is equals to mu into R, plus friction is always self-adjusting force acting in the opposite direction of motion. It should always be in opposite direction of motion. And in theory they can ask how there are two types of friction. One is sliding friction and one is rolling friction. You can imagine that in rolling friction, the area in contact should be less. See, it is rolling friction. Area of contact is less. But in sliding friction, area of contact is much. So interlocking is greater than in this case. So always remember, rolling friction is always less than sliding friction. You can decrease the friction by polishing the surface. But if you polish beyond a limit, it will increase the friction. Why? Due to strong adhesive forces, it will increase. Because molecules of two surfaces will attract each other and they will oppose now your motion. So this was all about friction. The next thing is, which is also important in this part, conservation of momentum. Actually, work power energy is also in this unit. What is work? I told you in vector, work is F dot D. If force applied is in the direction of motion, in this case, you can write it force into displacement. But what will happen if force is not constant? In that case, you have to take help of graph. If graph is not given, take help of integration. Means if force is constant, if it is dependent on displacement, firstly, small displace your object displace your object by a small amount so that you can take force constant and calculate that small amount of work. By integrating it in proper limit from where to where you want to displace, you will get total work. Or if you have a graph between force and displacement, area enclosed with the curve with the displacement axis, this will give you work done. This will give you work done. In case of variable forces, we can do this. So in competitive exams, they are giving 3 types of problems. First based on this, but they will not give 10 Newton force and 2 meter displacement, calculate work. They will give you F and D in vector form. They wants to check your dot product knowledge and work and force, and means they will check with one question your 2 concepts. Your vector they will check and your work power energy chapters concept they will check. Or they will give you force variable in terms of x. They will check your integration power. Or graphically how sound you are, they can check this. So remember always, if force is variable, either integrate it. If graph is given, calculate area bounded between your graph, your curve and displacement axis. So in this way, you can calculate work. Energy is nothing. Energy is capacity to do work. So what units you are using for work, same you can use for energy. For an example, if you are taking SI unit of work is joule, energy is also joule. But energy has so many different practical units. In work you are using joule or erg. Nowadays we are not using FPS unit. Say FPS unit was foot poundal. Poundal is the unit of force. Pound is unit of mass, but in FPS system poundal is unit of force. But nowadays we are using joule and erg, and 1 joule is equals to 10 to the power 7 erg. But in heat energy, we are using calorie. 1 calorie is equivalent to 4.2 joule. When you are using electrical energy in your house, you are using kilowatt hour. In electricity, sometimes we are using electron volt. So many practical units are there. Or you are using horsepower, very commonly used in engineering. 1 horsepower means nearly 746 watt. So many practical units are there for energy. So energy is basically, we are using in this chapter mechanical energy, means potential energy due to position or kinetic energy due to motion. Potential energy's formula is mgh and kinetic energy half mv squared. The important thing is this, that in so many times calculation of work is not easy, but calculation of energy is easy. So we are using work energy theorem. What is work energy theorem? Simple. Work done is equal to change in energy, either potential or kinetic. With the help of change in energy, you can calculate work done. Getting my point? If you have one spring and you are stretching the spring, the energy stored in spring you can calculate by this half kx squared. Energy of spring. you can calculate by the formula half kx square. It is stored in the spring in the form of potential energy. Power. What is power? Rate of doing work is power. dW by dt. Oh, we wrote this is the unit of power, horsepower. We are saying na horsepower, not energy. It is the unit of power, horsepower. It is horsepower 746 watt. Watt is the unit of SI unit of power. Watt. Watt is the SI unit of power. What is power? Rate of doing work. But for competitive, remember this formula, F dot V. F dot V is power. Since we are using dot product, it means it is a scalar quantity. So its SI unit is power. One more important concept in this chapter, so many times they are asking problems from that. That is law of conservation of momentum. Which type of problems they can give you? In this, one important thing is collisions. Collisions are of two types. Collisions, we have to discuss little bit this topic also. Collisions may be elastic, may be inelastic. What is difference between these two type of collisions? Elastic energy, elastic collision, kinetic energy, and linear momentum. Both are conserved. In elastic collision, I am writing there. In elastic collision, one is elastic and second one is inelastic. Inelastic collision, kinetic energy and linear momentum both are conserved. In inelastic collision, only linear momentum is conserved. So there are two types of collisions. When we are going with this elastic collisions, we can form two equations. Suppose it is a ball moving with velocity u1, its mass was m1. It was moving with u2, mass was u2. After collision, velocity of first ball was v1 and second ball was v2. We can form two equations. m1 u1 plus m2 u2, linear momentum before collision, it should be equal to m1 v1 plus m2 v2. And second, from kinetic energy, half m1 u1 square plus half m2 u2 square. It should be equal to half m1 v1 square plus half m2 v2 square. Cancel this half with this. Two unknown, two equations. Tough to solve. What we are going to do? Collect m1 on this side, m2 on that side. Same in that equation, collect m1 on this side, m2 on that side. Divide second equation by first. It is 2, it is 1. Divide 2 by 1. What you will get? m1 will cancel out, a square minus b square is a minus b into a plus b. So you will get u1 plus v1 is equals to, on this side, v2 plus u2. So now solving of 1 and 3 is very easy. Give it equation number. This original equation and this third equation. Solving of this is very easy. So now we are going to solve the original equation, which was m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. With that equation which we just formed, that is u1 v1, what we just got, one equation, u1 plus v1 is equals to u2 plus v2. If we want to eliminate v1, we are putting the value of v1 in that. If you want to calculate v1, put the value of v2. So we are getting m1 u1 plus m2 u2 is equals to m1 v1 plus m2. In place of v2, I am writing u1 plus v1 minus u2. So see what I am getting now. m1 u1 plus m2 u2 is equals to m1 v1 plus m2 u1 plus m2 v1 minus m2 u2. So now I am getting on this side, taking v1 common, m1 plus m2, on other side m1 u1 and this minus m2 u1 means m1 minus m2 u1 plus 2 m2 u2. So what is the value of v1? m1 minus m2 upon m1 plus m2 into u1 plus 2 m2 u2 divided by m1 plus m2. But if we are putting the value of v1, what we are getting in this, then we will get m1 u1 plus m2 u2 is equals to m1. In place of v1, I am putting u2 plus v2 minus u1 plus m2 v2. So now I am going to get the value of v2 m1 u1 plus m2 u2 is equals to m1 u2 plus m1 v2 minus m1 u1 plus m2 v2. So taking v2 on one side, I am getting m1 plus m2. On other side, taking u1 common, it is 2m1 u1 plus m2 minus m1 u2. So getting v2, 2m1 u1, similar result by m1 plus m2 plus m2 minus m1 divided by m1 plus m2 into u2. So many interesting facts are there now. If m1 and m2 are equal, what you will get? If m1 and m2 are equal, for competitive, a very important fact, v1 you will get, it will become 0, 2m2 cancel out, v1 become u2 and v2 become u1. Means if elastic collision is there and mass of two objects are equal, just only exchange of velocity, and so many other results you can deduce from this. And in elastic collision, there is only conservation of momentum. If two-dimensional, one more thing is this, if you are taking ratio of velocity of separation divided by velocity of approach, this is known as, denoted by E, coefficient of restitution. What will happen in perfectly inelastic collision? M1 and M2 both will stuck. It means velocity of separation will become 0. So remember, for perfectly inelastic collision, E will become 0, and for perfectly elastic, E will become 1. Why 1? Because what is velocity of separation? Now, V2 is greater than V1, so it is V2 minus V1. Initially, U1 was greater than U2, U1 minus U2. Since there is only exchange of velocities, so numerator and denominator will become same, so we will get 1. So V1 will become, V2 will become U1, V1 will become U2. So same thing is numerator, same is denominator. So what you will get? You will get exactly 1. So collision is again a very important in work, power and energy and Newton's laws of motion. Plus concept of friction, they can merge with force. So we have to deal with that also. We have to careful about all the concepts. Now what we are going to do, now we will discuss problems from competitive exams mostly based on this unit. 45 problems we will discuss now how to apply the concept in that. So you will learn these facts and you will learn this how we can apply them in solving when we are going to solve NEET problems.